In this video, we discussed the odd and even number sequence. So let's give a sequence of numbers 1, 2, 3, 4, and so on and so forth, right? And then let's say 5. So let's do the even numbers and do the odd numbers. The question is 0 and odd number. I'm sorry, 0 and even number. Well, I take the number 0 divided by 2. 0 times 2 is 0, right? I have remainder 0. Then I take the number 2. I divide it by 2, right? And I have 2 times 1 is 2, remainder 0. And I do it again for this even number here, like 4. I go 2, 2 times 2 is 4, remainder 0. Notice that 0 has a certain remainder. So now let's do the odd numbers, right? So let's take 2, 1, right? 0 times 0, 1, remainder 1. Let's take the number 3 and say 0, I'm sorry, let's take number 1, 2, 1, remainder 1. And let's take the number 5 here. Again, 2 times 2 is 4, like that. 1, remainder 1. So the odd numbers, when you divide by 2, have a remainder of 1. And the even numbers have a remainder of 0. We call this concept modulation, okay? Or modular, whichever one, right? So for an odd number, right, any number n is any number. If I divide it by 2, yields a remainder 1. We call this n mod 2 equals 1. That's where it comes from. Okay. For an even number sequence, you go even number. I take the number n divided by 2, I get a remainder 0. So the term n mod 2 is equal to 0. That's my modulation. That's how modulation works. Okay. Now from here, let's build it. Okay. So how do we push this into, let's say, more of a programming form? So in a programming environment,